Okay, table one, we'll start with you. Number one, the mean can be found by adding all the numbers in a data set and dividing by the number of numbers in the data set. It is true. I'll let everyone guess and remember it. Okay, what else do we call the mean class? Yes. Average. And we actually found the average last week, when we had the two numbers in the middle and we had to average them to find what the actual median was. I don't really use the word mean a lot, like average, I feel like is more what we say in the real world, but they mean the same thing. Average and mean are the same thing. So we kind of touched on it, maybe we didn't call it the mean, but just know mean and average are the same. And it is true that you find it by adding all the numbers and then dividing by the number of numbers. So that is not hard. You can use a calculator and add them up and then divide by however many numbers there were. Table two, number two, is the mean of the data in the dot plot four. You know what the mean is? Okay, so let's verify that. So we say false because the mean is the 3.5. So if this was a question on a test and it said like select all that are true, a way you can figure it out is actually calculating it. So adding up all these numbers, pull out my calculator for that. The one that I usually will show you on the screen is Desmos, because that one is in all your quizzes and unit tests. But I still strongly recommend you get a handheld calculator and practice using it. You can even check one out from the bookstore for free when you get your IEP. So please do that, preferably. But just to show you, we're going to add up all the numbers. Yes, if it shows up multiple times, you need to put it there multiple times. Just leave it off. And the sum of the data was 28. So you can see what I typed in. We want calculators that show us what we typed in so we can verify we typed it in right. And then you need to divide by however many numbers there were. So class, how many numbers were there in this one? 15. So we'll be dividing this by 8, and that is 3.5. So false because the mean is 3.5. The mean and the median are both measures of center, so that's why I think people get them confused a lot. Mean and median both tell us like what a typical value in the data set is. So like this one, 3.5 is pretty typical. It also probably is the median as well. But the mean is actually found by doing all the adding and dividing. So they're both very similar. You'll learn when to use one over the other. We'll talk about that in a different lesson. But first you need to know how to calculate both. Now, table 3, number 3. The median of the data set is 9 for this data. Would you agree? True or false? Okay, false. Do you know what the median is? Okay, so false because the median is 5. So yeah, that's a common mistake is people just look at this and not notice that it's out of order. With mean, it doesn't matter. You could put it out of order in your calculator and it'll still add up to the same thing. But median has to have it in numerical order. So when you do that, I'll try to squeeze it in here. And then you start going left, right, left, right. We had an odd number of data points, so there's just one number in the middle. And that's fine. So the median. Median, I know you don't really drive yet, but like that's a way to remember it. A median is in the middle of the road. All right, lastly, table 4, the median of the data in the dot plot is 3.5, true or false? Do you know what the median is? Okay, but you just think it's not 3.5? Yeah. Okay, so let's see. When it's a dot plot, I wouldn't probably waste my time writing it out in a list, but you can, like, if this was a quiz on your computer, like, you can get scratch paper and write it out so that way you can do, like, the crossing off. But we just go left, right, left, right. If you count how many data points you had originally, I think there was 12 in this one. I usually will just check that so that I know, like, I'm gonna average the 2 in the middle or not. All right, so I have 2 numbers in the middle, 3 and 4. Gas is 3.5 right in the middle of 3 and 4. Or in other words, you could average them, 3 plus 4, and then divide by 2 because that's how many numbers. Is it 3.5? It is. Use a calculator. Divided by 2 is 3.5. So let's change that to true. Because, and you can count it out, I think there was 12 data points. So 1, 3, 6, 7, 8, 9, 10, 11, 12. You should expect to take the average of those two numbers if there's an even number of data points. So my 2 numbers in the middle are 3 and 4, not like the 2 numbers in the middle of the number line. Once you cross off each data point, I have a 3 and 4 in the middle, I average. All right, questions, comments, concerns? All right, so today's lesson is to practice calculating measures of center and measures of variability. So measures of center, we just did an example of those in the warm-up. Those would include things like the mean, which is also called the average, and then also the median. So those tell us a typical value. It tells us what the data is clustered around. They're calculated differently, but they both tell us a measure of center. A measure of variability, we've already covered some of them. So measures of variability in a previous lesson, we talked about like range, so like maximum minus the minimum. We talked about IQR, which is Q3 minus Q1, so it tells us how spread out our data is. So think about when we talked about our survey questions and how if I asked you all like what month is your birthday, we wouldn't expect everyone to have the same answer, right? But you expect some variability. So these are measures of how spread out. Yeah. Then the learning targets, you can actually probably cross off some of them because we have practiced those before. We've practiced calculating IQR, calculating mean and median in the warm-up. You will learn how to calculate mean absolute deviation today too. Side note, tomorrow you have your benchmark testing, and then again, like I've been telling you, calculators, super important to get one. Because the calculator that will be embedded in your state test in April is not. So let me show you that. One day we will take the ATT Aspire exemplar, but showing you the calculator that you're stuck using if you don't bring one to your testing day, and that's this one. So like for your benchmark, it might be different because the benchmark isn't given in the same platform, but for your state test, it's this calculator. Is it about this? Okay, so wait a second. So this calculator is no good because it only lets you see one number at a time in the window. And say you were typing in some stuff, you only get your answer when you hit equals. So whatever calculator you plan to bring or use, you have to know how to use it. And this one is no good. It doesn't even show you what to type in. It does do order of operations still, but like you really have to pay attention to what you're typing in order for it to do that and then still remember it. Okay, so that's what I'm saying. Even though I show you a lot of things in Desmos, which you'll have access to on your creative intermediate test, like that's the most accessible to you because you all had to check out a Chromebook anyway. Let's make sure everything's open. Even though I show you a lot of things in here, it's still good for you to get a calculator and literally you just type in whatever model it is in YouTube, whatever you're trying to figure out about it, and then it'll teach you how to use it. But there are some that are not allowed, and it's the ones that say CAS in the corner. Don't get those ones. I'm not sure why these other ones are pictured. Maybe those are also prohibited. But really the ones that say CAS are usually more expensive anyway, so not a lot of students ever receive them. You need to get one that's allowed and then start practicing. Yes. So tomorrow would be a good day to start practicing because tomorrow's test is supposed to mimic your state test a little bit at least. You probably won't have enough time to finish your test tomorrow, but you're going to try your best. But back to today's lesson. I'm recording right now. It'll be linked right here. There's some other videos from prior years if you'd like to check those out. The practice is in Schoology. It's auto-graded. Now I still have to press a little button in Schoology that will sync it to the online gradebook, but you can see yourself if you turn in your stuff. Everything so far has been turned in digitally, except for like your syllabus. So, you know, your missings are coming from you not doing your online homework or hitting submit. I do put in missings as we go, so if you don't want missings going to the gradebook, turn them in the day that they're assigned, which is today. Benchmark tomorrow, you'll have your first quiz on things that I've actually taught you on Monday, so make sure you have your notes ready and helpful for that. We're gonna go to this question on our notes. The one about heart rates of 8 high school students are listed below. What is the interquartile range? That's review. How many values are in the data set are less than Q1, between Q1 and the median, between the median and Q3, and greater than Q3. So practice that. Take out your notes from last week if you need to. We'll go over this one in 5 minutes. Define the interquartile range the way that the data is set up right now. And why not? Okay, good. So if you immediately started trying to find the median, you forgot a very important first step, which is to start putting it in numerical order. So class, what's the smallest number?
72.
Then the next one. The next one.
76.
The next one. Okay, and then once you've made your list, double check. I started with 8. I need to have 8 different numbers in my list. So 1, 2, 3, 4, 5, 6, 7, 8. Then you can effectively start finding your IQR. Table 1, what's the formula for IQR? Okay, so I'm not looking for the answer, I'm looking for the formula for IQR. Like a definition almost, but IQR is always found by doing what? Okay, good. All right, let's talk to table one. They figured it out, so we gotta let them do it. So what is the interquartile range? Well, first you need to know how to find the interquartile range. The formula for that is Q3 minus Q1. Now, remember that's your upper quartile minus your lower quartile. Before I find the median of my upper half and the median of my lower half, I need to find what first? That's in all of you. The median of the whole thing. So that's why we put it in numerical order. Then you could start going left, right, left, right. And because I had 8 numbers to start, I should expect there to be 2 numbers in the middle that I average. Class, what's the average of 76 and 77? 76.5. You could actually add them together and divide by 2, or since they're pretty easy to figure out what's right in the middle of them, that's a good start. So that's my median of the whole thing. That separates it into my lower half and my upper half. I'm going to find my Q3 first because I need that first. So I'm going to go left, right. Table 2, what's my Q3 going to be? Q3. 78.5. So here's my upper half. Here's where the middle would be. I have to average these 2 numbers. And that's 78.5 for my Q3. So when I'm starting to plug that into my formula, it'll be 78.5 minus whatever my Q1 is. Table 3, what's my Q1? Say it louder. Not 76.5. So go left, right. Oh, 75.5. That would be right in the middle of 75 and 76, right? Or you could actually do the math, add them together, divide by 2. Still 75.5, that's our Q1. So then table 4, what's my IQR? 3. So the IQR is a measure of variability. It tells you how spread out the middle 50% of your data is. Remember that the quartiles spread your data or split your data into quarters. So here is my middle 50% right here. We're saying that it's spread out by 3 numbers. Notice like 3 is not a typical number in the data set. My data set is not anywhere near 3. It's telling me it's spread out by 3. All right, so any questions on that? So if the test said, what's the best measure of center for a data set that looks like this? You should not be saying IQR because IQR is not a measure of center. Okay, it's a measure of variability or spread. Moving on, unless you have questions. Table 6. How many values in the data set are less than Q1? Okay, so my Q1 was 75.5. How many values are less than that? Six. So here's my data. We know our Q1 is 75.5. How many of our data points are less than 75.5? 2. Table 1, how many values in the data set are between Q1 and the median? or one with no that we're called on. How many values are between Q1 and the median? Three. So my Q1 is 75.5, my Q2 or my median is 76.5. How many numbers are between that? 2. Visually, you can see it over here. Here's where the quartiles are. When they're in the middle of numbers, you put them like draw a line in the middle. There's 2 values that are between those 2. Table 2, how many values are between the median and Q3? 2. And table 3, how many values are greater than Q3? 2. So because our quartile splits the data into quarters, there should be like an even amount in each section. Data points, 2 data points together. Yes. Questions on this? Good. A little bit of review from last week. Moving on, so that's one measure of variability. We already kind of knew how to calculate it, but now you know it tells you how spread out the data is. Let's look at a new measure of variability, which is called the mean absolute deviation. So we're gonna find that by hand today. It's usually a long process. So really after 2 minutes homework, you'll probably never have to find it by hand again. But that's where like knowing how to use your calculator comes into play. I'm gonna teach you how to use the calculator on Thursday and Friday. And if you have a different calculator, you could look up whatever model you have and see if they can calculate it for you. But we're going to calculate the mean absolute deviation, MAD for short. But you need to know both because on your quiz it might say find the mean absolute deviation. You have to know that it's. And also the name kind of helps you remember how to calculate it. So the word mean. How do you find the mean? And yes, 3 and 4. Good, and that was the very first one on your warm-up. We said it was true. It was like a sentence basically on how to find the mean. Here's another way to think about it. Mean equals the sum of your data divided by, so fraction form, divided by the number of data values or data points. So this is the same data we were just looking at. We found the IQR of it earlier. We're now going to find the mean of it because that would be the first step in finding the mean absolute deviation. I need to find the mean of this data set. So go ahead and do that real quick with your calculator, whether it's a Chromebook or like a real calculator. Find the mean, and you're going to put it in this column. It's the same number here, here, here. I'm going to freeze my screen and do the same.
That's the first step in finding the mean. You just got to add them all up. And you can use a calculator. Now, did you include the other 76? It should be 614. So let me see. Yeah, I think if you don't include the second 76 value, then it is that number you said. But you have to, like, if it shows up twice, you have to include it twice. So it should be 614 when you add them up. And then table 1, how many data points were there? Table one, how many data points were there? Guys, you need to stop asking me when I'm in the middle of trying to teach you. Table one, how many data points were there? You just have to count how many numbers there were. Oh, okay, so how many? 8, good. Okay, so that's step one. Well, really step two. First, you add up all the numbers. You can use a calculator. Then you have to count how many numbers you just added together. Should match the number of data points you were given. And then you just put it in your calculator again, and you get that the mean is 76.75. All right, so there it is. That is how you do it. Even if you were like really bad at math before, it doesn't matter because this is all stuff that you could put in your calculator. You should just be able to do that. All you have to remember right now is some like formulas a little bit, like mean. But right now, when you can look back at your notes, you should be able to see how exactly to find it. Have it memorized by the unit test. So 614 is added up. This is me dividing it by 8, the number of data points we had. That's my mean. I'm going to put it in this column all the way down. Right, and it's going to be the same number all the way down. The mean does not change. Now, we were breaking down what MAD is. So it's mean absolute deviation. Deviation is how far something is from something else. So what we're going to find is how much each data point deviates from the mean, and we're just going to subtract them. It really doesn't matter what order you subtract them. I mean, it has it as data value minus the mean, so you could just make it simple. 72 minus 76.75 is negative 4.75. So that's what's going to go in this column. 75 minus 76.75 is negative 1.75, and so on. Put that in this column. So that's the deviation part. We need to also find the absolute value. Do you guys remember what absolute value is? So it's not parentheses, like it's these little bars that go outside of a number, and they tell you to take the absolute value of that number. What's the absolute value of 3? How far is 3 away from 0? 3. What's the absolute value of negative 3? Also 3. So in like really simple terms, if it's negative, the absolute value of it would become positive. If it's positive, the absolute value would still be positive because it's how far is something away from 0. So then in this column, when it gets to absolute deviation, take the absolute value of this. The value of negative 4.75 is 4.75. The absolute value of negative 1.75 is 1.75. Let's do one where it's positive. So for the next row, I'd be doing 81 minus 76.75, and that's 4.25. What's the absolute value of 4.25? No. 4.25. You should never have an absolute value be negative. So if it's already positive, it's still positive. If it's negative, it'll be something. So do that for the rest of the rows. Find the deviation from the mean. So subtract them here. And then find the absolute value of it here. Now, okay, Dexter, what is the deviation from the mean for 76? Mm-hmm. So like in this column, the data value minus the mean.
Oh.
So technically the way that they want you to do it is to do 76 minus 76.75, which would be negative. Since we're taking the absolute value, it doesn't really matter because it'll end up being positive anyway. But just so you know, like order and subtraction does matter. But for this, when we're finding the absolute value, it just makes it positive anyway. Let's see. Brianna, what about for 77? Let me double check that because I'd be doing 77 minus 76.5 or 76.75. I got 0.25. Make sure we're doing 77 minus our mean, which is this. It's 0.25 of a difference. Let's see. Ricky, what's the absolute value of 0.25? Good. All right, Colton, what's the deviation from the mean for 79? All right, and that should be positive. Good. Because we had a bigger number minus the smallest number. And class, what's the absolute value of 2.25? 2.25. And then we have Josiah, what's the deviation from the mean for the 78? All right. That is correct. And class, what's the absolute value of 1.25? So in this column, everything should be positive. Now we are going to find the mean absolute deviations because we actually haven't found it yet. We've done all the little pieces leading up to it. We found the mean, we found how much each data point deviates from the mean, and then took the absolute value of it. The mean absolute deviation has me now taking the mean of this. So now I'm going to take the mean of all my absolute deviations. So you should be adding up all these numbers, dividing by however many numbers you added. So that should still be 8. And then that will give you your mean absolute deviation. You should be trying that too yourself. Don't just wait for me to do it. You can all add in a calculator, I'm sure. And if you added them correctly, you should get 16. And then, of course, divide by however many numbers there were. The mean absolute deviation is 2. So it's a way to measure how much our data is spread out on average. So it's different from IQR. IQR only looks at the middle 50%. The mean absolute deviation looks at your entire data set. So that's where it's a long process. Again, after tonight's homework, you won't have to really find it by hand again, but you do need to understand. 2 is not anywhere close to any of these data values. So it's not a measure of a typical value in a data set. It's a measure of how spread out my data is on. Questions, comments, concerns? So the other part of your learning target, I think we actually cover in a different lesson. You'll learn which one is more appropriate based on how the data is distributed. But since the MAD uses the mean in its
procedure, anytime that you prefer the mean, you're also gonna prefer the math for the variability. And because when we find the IQR, we had to find the median first. Anytime we prefer the IQR, we also prefer the median. So like they each go hand in hand. And you'll learn why we would do one of them together in a different lesson. All right, so that covers it for today. I do think the questions on your notes, like where it says lesson synthesis, and the ones on the front that we didn't necessarily write out, I do think that those are good questions for checking your own understanding. Another way to check your understanding is to score 80% or higher on the practice. It also gets started on right now.